Okay, can you hear me? Can hear or not? Okay, can you see the
Can, teacher.
geometer sketchpad, the screen?
Can, teacher, can.
Okay, right. So we're going to start. See anyone coming? They are still in school. Are they in school? Three of you back. Only three. The others still waiting for.
Yeah, teacher, I ask them. I ask them.
They are still waiting for their bus. Okay. Okay, Sarah, today you are very good. Okay, right. This one I don't know whether they are interested or not. So I start with this, right? Now, this is what we have learned in the last lesson about limit. Now, if they ask us to find the limit, then very easy. But the problem is they ask us to find the value of k. Okay, they ask us to find the value of k. Now, when I look at this, the function at the top, k square, sorry, x square minus k. Now, x square minus k can be expressed as x plus square root of k, x minus square root of k. Okay, because this one is the b square, a square minus b square. So k is actually b square, right? So I can actually write this as square root of k. Some of you, you don't understand, so you ask me, hey, why, why is it like that? So now I better write down square root of k so that you understand, right? So if you try to factorize this, it will be square root of k. Okay, so I treat this as a square minus b square, so it's a plus b, a minus b. So the a square is the x square, and the k is the b square. Since they did not give us in terms of k square, they give us in terms of k. So in order to get the factor on this side, so I say it is the square root of k, the square root of k. So square root of k square, it will be k. Now the second thing is, this is for the first function at the top, at the numerator, and at the denominator I have this factor 3 plus 3x minus 6. But when I look at the limit, it is x approaches 2. So if x approaches 2, it means that the x must be equal to 2. So if x equals to 2, let me continue here. Okay, let me continue here. We have this one, x approaches 2. So that means x equals to 2. Now if x equals to 2, that means x minus 2 must be a factor. X minus 2 is a factor. So when I look at the bottom here, the denominator, I cannot see x minus 2 as a factor. Okay, I cannot see x minus 2 as a factor. So I try to factorize. So when I factorize, take out the common factor 3. So I have 3 bracket x minus 2. Now you see the reason why they say as x approaches 2. As x approaches 2. Okay. So far, okay or not? So far, do you know the factor here must be square root of k, this one must be square root of k, and I want to factorize this because I want to match it with the x approaches 2. So far, any question or not?
Teacher, can repeat.
Repeat. Okay, now there are two things that I see from this problem. That the first problem I can recognize, sorry, not the problem, the first hint. Okay, I can recognize that x minus k is actually a square minus b square, because there's no number in front of x here. So I assume that the x square is x square is a square and b square is the k. Now in this way I can factorize it out. Now why I want to factorize this? so that I can cancel away the factor at the bottom here, so that as x approaches 2, I won't get infinity. Once I cancel away the factor x minus 2 with one of the factors at the numerator, then even if x approaches 2, there will be limit. Does that enlighten you a little bit, or you want me to how
Uh,
you ask some more? Anyone else? Sherwin, can you ask some
Sir, I
question?
don't understand, sir.
Don't understand. Now, for this question to have a limit, they ask us, given that the limit is 4 over 3, right? 4 over 3, find the value of k, right? Now, in order for this problem to have a limit, okay, I must cancel away the factor x minus 2. You see, in this case, if x approaches 2, 2 minus 2 will be 0. So something divided by 0 will be infinity. Yes or no? So there won't be a limit 4 over 3 there. Okay, now? So in order to have a limit, I must cancel away x minus 2. Okay, now?
Okay, sir,
Okay.
understand.
So in order to cancel away this x minus 2, I have to factorize the top. Now, luckily, I know a square minus b square equal a plus b, a minus b. Now, in this way, I can factorize the top so that it can cancel with the bottom there. So what should the number at the top be? What should the number at the top be? In order to cancel with the bottom here. So definitely,
2.
the question mark here must be 2. This number here must be 2. So if this number here is 2, so that it can cancel away, so that the limit for this question exists, right? So it has to cancel away. So this question mark must be 2. But the question mark is what? Square root of k. So I continue here. The square root of k, right, equals to is equals to 2. So the square root of k equals to 2. You square both sides of the equation, k must be 4. Okay. Clear or not, this one? Clear, then I go on to the next
Okay,
Yes,
okay.
sir.
Clear. Okay, clear, then we go on. Let me see how many of you already. Five of you. Who are the five? Yalian, Sarah, Zini. Okay, right. The others still waiting for the baskola. Okay, right. We continue the next problem. The next problem is more complicated. Why? Because there are two unknowns here, h and k, and yet they say x approaches -1. Now x approaches -1, right? So there must be a factor. Okay, let me see. There must be a factor like this. Okay, if they say x approaches -1, that means x equal to -1. Okay. So x equals to -1. If x equals to -1, that means x bring over become x plus 1. X plus 1 must be a factor. Now, so if x plus 1 is a factor, right? But here is x plus 2. X plus 2. How to make this x plus 1? Now, from our past experience here, we know that we can factorize out the common factor. But here, the common factor, we don't know. So what must we put as k in order that we can factorize the denominator so that the factor become x plus 1? What must I put for the value of k? So come back here. Now, if this k is equals to 2, then it will be this k here, k equals to 2. So k x plus 2. So it will be 2x plus 2. Now, if k equals to 2, I can factorize out already. Take out the 2, and then the factor become x plus 1. So if the factor is x plus 1, then this x equals to -1 will make this undefined. So when x plus 1, I have to create something at the top so that it can cancel away the factor x plus 1. Okay or not so far? One more time. I look at the hint here. The hint is x minus 1. If x minus 1, x equals to -1, you look here, then you bring the -1 over, become x plus 1 equals to 0. So that means x plus 1 must be a factor at the denominator here. Now, how to make x plus 1 a denominate at the denominator when there is a k in front? So I should actually put a certain value for this k so that I can take out the 2 here to make it x plus 1. So what is the value that I have to put in front so that I can factorize this thing and make it x plus 1? So the value of k must be 2 so that I can factorize and make x plus 1 a factor at the denominator. So far, okay or not?
Okay, sir.
Okay, yeah, sure. Zini, Sarah, Jia, Yen. Okay, right. So now, okay, then we move on. Now, when I substitute k for 2, that means I replace the value of k with 2 and I factorize, it becomes something like this. Now, x plus 1 is a factor at the bottom. I need to cancel away the x plus 1 at the top. Okay or not? So that I can say x approaches 1, -1, the whole thing cannot become infinity. So I have to create another factor of x plus 1 at the top so that it can cancel away. Now, how to create a factor of x plus 1 at the top? Now, this is a quadratic equation. This is a quadratic equation. You have learned last year that a quadratic equation has 2 roots. Now, if you are given one of the roots is -1, how to find the other roots? How to find the other roots? Or maybe you don't have to find the other roots. You just need to find the value of h, isn't it? So if you know that x plus 1 is a factor, x equals to -1 must satisfy this expression at the denominator. Okay, so if you know that such a number, let's say x equals to -1, is a root of the quadratic function, then the value x equals to -1 must satisfy that expression. So it means that if I put in x equals to -1 into the expression, at the numerator, then it will be equal to 0. It will satisfy the expression because this is a factor, this is a root of the equation, and the root of the equation always satisfy that equation. Okay, now, so if we satisfy the equation, I can substitute x equals to -1 into this equation, and from there, I can get x equals to 3. Okay, now, another way is to factorize the top there, but then you don't know what is the value of h. It's very difficult for you to factorize. Anyway, we are not interested in what is the other factor, right? What is the other factor? So let's say now we know h equals to 3. You substitute, you know x equals to 3. Then the quadratic equation becomes like that. It becomes like that. Okay, it becomes like that. Where is it? This one. Okay, the quadratic equation become like this. Okay, then I paste here, right? Then now I know that h equals to 3, so I put there 3 because I found out the value of h to be 3. Okay, then make it red color. So one of the factor is x plus 1. One of the factors of x plus 1. What is the other factor? X. this is x plus 1. Huh? What is x plus 1? And what is the other factor there? X minus 3. X minus 3. So that you can actually get h equals to 3, right? So if you factorize this, then you put inside here. Now the x plus 1 and x plus 1 can cancel away. So if x plus 1 and x plus 1 can cancel away, right? And what do you think? Okay, so this one is no longer this, because we know x equals to h equals to 3, x plus 1, x minus 3. Okay, so you can see that it will cancel away. It will cancel away. The x plus 1 and x plus 1 will cancel away, so there will be limit. But we are not interested in finding what is the limit. We are interested in knowing what is the value of h, right? So h is 3, and 3 plus 2, answer will be 5. Answer 5. Okay, this one need to explain one more time, but I don't know where to explain, where to start explaining. So you have to ask me some questions so that I know, oh, this is the part that you don't understand. So I start explaining from there. Okay, so you ask me some question. Louder, please. It's raining outside. Can you hear the rain?
No, sir.
You cannot hear the rain. Never mind. Okay. Understand. Sure, understand or not? Really? Oh, very good. No question. And the other girls ask question. Other girls
Understand.
understand
Understand.
also. Okay. No, for those that don't understand, maybe I explain one more time, right? I explain one more time. So where to start? I start from here, right? From here, they say x minus 1. So in order to create this x minus 1, that means the factor must be x plus 1. How? You just bring the minus 1 over x plus 1, 0. So in order to create that factor x plus 1, I have to put k equals to 2. So when I put k equal to 2, then I can factorize. Then, oh, I see, x plus 1 is a factor. So I put inside here, k equals to 2. Then k equals to 2 can factorize. And the factor at the bottom is x plus 1. But the problem is the factors at the top. The factor at the top there, we don't know. And again, I know the factor at the top, the factors, one of the factors must be this one, x plus 1. So if x plus 1 is one of the factors of this quadratic equation, so this value x plus 1, which in turn become x equal to -1, must satisfy the expression at the top there. So if we satisfy the expression at the top, that means there will be a fraction of this form, x plus 1 there, and they can cancel away. But I'm not interested in what are the factors. Well, actually, we know the factors, they are x plus 1 and x minus 3, and they will cancel away, and so on. Okay, but I want to know what is the value of h so that they can cancel away. So what I do is, I use this value x equals to -1, I substitute into the expression. So when I substitute x equals to -1 into this expression, which I am sure it will satisfy this expression, right? I get h equals to 3. So I know the value of h must be 3. Okay, so 3 plus 2, 5. Right? Next question. Okay, next question is, this question actually is from the last chapter of Form 5. This question is actually from the last chapter. Is it from the last chapter? Let me see. Let me see the textbook. Refer to the textbook. Okay, the textbook says this one. Where is it? Yeah, this is the chapter, or chapter 8. Sorry, chapter 8 of Form 5, and the name of this chapter is let me see. Chapter 8, Form 5. the name of this chapter is what? Displacement velocity. Displacement velocity, or they say the name is kinematics of linear motion. Kinematics of linear motion. So you go home, you look at chapter 8, right? You look at chapter 8, and this topic that we do now, this one here, this question is actually from chapter 8, but never mind, I will explain to you, right? Explain to you. S is a function of t. Now, what is S? S is the displacement. Now, if you have learned in your physics, displacement is actually the position, right? The position of the particle. A particle is moving along a straight line, and displacement is the position of the particle. And another one, I want to introduce another symbol, V. V is the velocity, and this is also what you have studied in your physics. Any girls from the account class? Li Yin, any girl from account class or not?
Today I think they didn't enter for the account classes.
Who are they?
The Jia Ying, Kai Hui, they are.
Jia Ying is here, isn't
The
it?
boy. No, that one is Jia Yan. The one is the Tan KH, the boy, and the girl. Got one, the Chia Jia Ying.
Oh, okay. So three of them from the accounts class. Okay. Now, if they're from account class, I think they have not studied this before. Now, never mind. Okay. So the symbol, they are S for displacement, V for velocity, and T for time. So I have defined the variables here. Now, the second one is, what is velocity? Velocity is the rate of change of displacement. So it is here, rate of change of displacement is the displacement divided by time, is the S over dt. Okay, right. So what is the S over dt? Hey, teacher never learned before. You only learn what is dy dx. Never mind, now you learn. Now, dy dx is you differentiate y with respect to x. Now, here what we are doing is we differentiate s with respect to t. So it becomes ds dt. Let's say if I differentiate a with respect to b, so it will be dA dB, like that, right? So differentiation is a general term. So you cannot say it's only for y and x. It can also be used for other variables, other symbols. Okay, so differentiation, the dd is actually a process, right? It's actually a method, a process. Okay, right. So now we are looking at ds over dt. Why we want to find ds dt? Because ds dt is the velocity. The rate of change of displacement is the velocity. So how to differentiate? They want from the first principle. From the first principle, I have to put s plus delta s, t plus delta t, and here also t plus delta t. And you expand. After expanding, you use equation 2 minus equation 1. Now all those terms without delta, they will cancel off. So next time you don't worry. You want to first principle, you just pick up the ds, the dt, or the dy and the dx, the delta y and the delta x. All those without delta one, they will cancel off. Okay, so they all cancel off, and you are left with this one. Delta s equals to 2t delta t minus 3 delta t plus delta t squared. Okay, and after that you have to divide by delta t. Divide by delta t, delta s over delta t. This one divide, you only left with 2t. Divide, you are left with 3. Delta t square, you divide with 1 delta t, you are left with 1 delta t. Okay, then what is the s dt? The s dt is the limit of delta s over delta t as delta t approaches 0. So I take this expression here, I substitute inside the delta s over delta t. It becomes like this. Now, as delta t approaches 0, that means this one will be 0. We are left with 2t minus 3. So what is the velocity? The velocity is 2t minus 3. 2t minus 3. Now, after 5 seconds, what is the velocity? So you have to substitute 5 inside the velocity equation. Okay, don't substitute inside the displacement equation, because you are not asked to find the displacement. You are asked to find the velocity. So you substitute x equals to 5 into the velocity equation. Velocity equation, then you will get v equals to 7. V equals to 7. So they didn't tell us whether it's meter or not. So if meter, it will be 7 meter per second. If it is unit, it will be 7 unit per second. Okay, any question?
No, teacher.
No, no. Wow, good. Now one more student already. Ang Yifen is with us now. Ang Yifen. Okay, right. One more. 5, 6, Ang Yifen. Okay, right. So now we come back to this. Not this, not this, this one. We close this first, huh? Close this, close this. Okay, right. Now we are going to look at differentiation. Now you're going to ask me, hey, differentiation we have learned before. Differentiation is differentiation from the first principle. So differentiation from first principle, what are you supposed to do? You are supposed to find dy dx. How are you going to find dy dx? You find it by finding the delta y over delta x. But that is a very tedious process. As the function become more and more complicated, and if you want to use the first principle, you need to have a very advanced knowledge of mathematics. But you don't have the advanced knowledge, so that means some of the function you cannot use the first principle anymore. But don't worry, we have generalized how to differentiate without using the first principle. Of course, this one it cannot be explained, right? The first principle you can explain, but this one is the generalization that we learned after we see so many differentiation. We come up with a generalization how to differentiate a function. Okay, now let's say if we have a function like this, y equals to ax to the power of n. Do I need to go through this? Differentiation is a process of obtaining the derived function, or maybe known as differential coefficient or the first derivative. So if you want to get that first derivative, that process is called differentiation. So how to differentiate this thing? How to differentiate this thing? Now before that, let me explain to you y is a function of x. This a here is actually a number multiplied with x. And what is the n here? The n here is actually the index of x. So it can be x to the power of 3, x to the power of 4, x to the power of negative 7, and so on. That is the index for x. N is the index for x. What is a? A is actually the number that you multiply with the x. Right? Or in general, if you want to differentiate this function ax to the power of n, this number a in front here, you don't differentiate it. You just leave it, copy back the same. Then the index, the n, you put in front. You put in front here. And the index here will be less by 1. So it becomes n minus 1. So it sounds very confusing because we don't have actual numbers. So afterwards, I'm going to give you numerical examples. So I'm going to substitute a and n with numbers so that you can see how to differentiate, right? So that you can see how to differentiate. Okay, so what you need to remember now is the method, the shortcut. Instead of using the first principle to differentiate, what is the shortcut that you're going to use to differentiate a function? Okay, so the shortcut is like this, right? If fx equals to ax to the power n, then f prime x equals to a n x to the power of n minus 1. Okay, so same formula. Okay, same formula, why I write two times there? Now the first time the function is known as y. So the derived function is dy dx. The second time the function is called fx. The derived function is called f prime x. F prime, like a comma like that. F prime x. Now this f prime x, I must tell you, it is different from the function that you have learned in Form 4. In Form 4, you learn there is a fx, f2x, f3x, f4x, and so on. Here, there is a little number above the function there. That one is for composite function. So composite function, you can put numbers there, 1, 2, 3, 4, in place of this prime there. That is strictly for used for composite function. For derived function, we're going to use prime. 1 prime, 2 prime, 3 times, you prime it 3 times. These are used to represent differentiation, used to represent derived function. Okay, so derived function you have to differentiate. Composite function you have to substitute. So there are two different things. So far clear or not? Anybody got any question to ask?
So teacher, the formula is we find the fx or f prime x.
Again, the formula.
We use the answer will ask like find for fx or f prime x
Find f prime x. The derived function is f prime x, so you have to find f prime x. Or here they will ask you to find dy dx. Okay, sometimes they will ask you to find dy dx. It means that you have to differentiate. It means that you have to find the derived function. Or sometimes if the question tell you is fx, then they won't ask you to find dy dx because there's no y there. How to find dy dx? So if the question is asked in this form, fx, then your answer will be f prime x. It's just the notation, a different way of writing, but it means the same thing. Now another time, sometime they will just say, hey, differentiate ax to the power n with respect to x. Then if you look in front of this ax to the power n, there is no f, no y there. Alright, so if I want to find dy dx, I will say d dx of this function here, the given function, d dx of the given function. What does d dx mean? D dx means differentiate with respect to x. So I'm going to differentiate with respect to x this given function. Okay, and what's the answer? The answer is still the same, a n x to the power n minus 1. So you have to remember this lah. You have to remember this. So how many ways of representing a function? You can call it y, fx, or an expression of x like this. So the derived function will be dy dx, f prime x, d dx. So far, I am telling you the notation. Any question? No question, then I will show you numerical examples.
Okay, sir.
Okay, so we are going to look at a certain a few. We are going to look at a few numerical examples where the a and n become numbers. Okay, so the first function we want to look at is 2x to the power of 3 and differentiate with respect to x. So since there is nothing in front of this function here, so when I differentiate, I will call it d dx. d dx of this function equals to. Right, so the first thing I told you is the number here, you don't differentiate, you just copy down. Then the 3, you copy the 3 and put in front here. Then the index less by 1, 3x minus 1. Okay, so numbers and numbers, you can multiply together. 2 and 3 become 6. Then this one, x minus 3 minus 1 is 2. So the answer is 6x squared. Now, what I want you to remember is you don't write out this step. Right, this step. You do mentally? Can or cannot? If you cannot do mentally like that, when the problem become more and more complicated, then every time you have to write out n minus 1, n minus 1, 2 minus 1. Don't need, no need, right? So you have to do it mentally. Okay, now? So how to do? Bring down the 2, the 3 also bring down, then the 3 less by 1. So 2 times 3 is 6, then x less by 1 become x to the power 2. X to the power 2. Do mentally. No need to show this step next time. Just do mentally. 2x cubed, 6x squared. Give the answer like that straight away. Okay, right. Okay, so the next example is find the first derivative of fx equals to 3 over 2 x to the power of 5. Now this one, you want to do mentally, not so soon, not so soon. Yeah. In future, hopefully you can do mentally. If you cannot do mentally, then you have to give this function, you have to change it to this form. Change it to this form, then you differentiate. Okay. Now, these 2 over 3, they are actually numbers. You cannot differentiate. So you take out the 2 over 3. Then the 5 at the bottom is actually 1 over x to the power of 5. So it is 3 over 2 x to the power of negative 5. So far, have I differentiated the function? Not yet. So not yet. This person, the name is still fx. Now, once you have differentiated the function, or you undergo the process, bring down the power less by 1 and so on, then it is no longer called fx. Once you have performed the differentiation, the name is f prime x. Any question? So over here,
No.
fx, okay. So over here, the fx becomes 2 over 3 x to the power negative 5. Even the 2 here, you have to take out, The 2 is at the bottom. You don't follow the 2, don't follow the 5, then your 2 goes up. 2 cannot go up. Only the x can go up. So when the x go up, it become negative 5. This is index you learn in Form 3, I think. Right now, Form 3. You learn this in Form 3. So 1 over x to the power 5 is x to the power negative 5. So this is still function. It is not the derived function. So this is still called fx. So now I'm going to differentiate. When I differentiate, the number 3 over 2, just leave it outside. Then the negative 5 you put in front. Then the negative 5 less by 1 become negative 6. So negative 5 multiplied by this, negative 15 over 2 x to the power negative 6. You want to bring back the negative 6 to the bottom? Can. You can bring down like this. So this is going to tutup. So tutup.
Teacher,
Yes.
if didn't bring down the x minus x negative 6, correct?
Still correct. You have already differentiated. It is called f prime x. It is no longer called fx already. But some cases, they want you to make it look more beautiful, then you bring down. Right? Look like the original one. The format is like the original one. Okay, we stop here, then we generate a new Zoom password, new Zoom
Okay.
link. Okay.